Good morning, everyone. My name is Johanna Miller, and I am the marketing specialist for E&M. Thank you for attending our Learn in 30 webinar today focused on Rapta. After the webinar this morning, we will be doing a short Q&A. Please type any questions or comments into the Q&A box or chat, and we will get to them at the end. I'd like to introduce your presenter for today's webinar, Matthew Thornton. Matthew is the founder and CMO of Rapta AI. Good morning, Matthew.
Thank you, Johanna. Hey, everyone. Matthew Thornton, as she said, one of the co-founders of Rapta, I believe 25 years now in the manufacturing industry, doing this ever since I graduated from university. Okay, so the basic architecture of a system that we deploy for applied AI for quality control applications, whether we're talking sub-assemblies, full assemblies, robotic, and or automated. Ultimately, this example is a human work cell where I'm doing the final assembly for this little PC that I'll show you here in a few moments. Ultimately, what we've done is there's an array of cameras over this target. You'll see I have some above, some behind, and I have some to the side profile. And the reason that we do that is we try to emulate how a human sees a target. If they bob and weave their head around the target, we need to have cameras around it to see those specific edges and features. We always have an HMI as well. That's the human machine interface that they interact with our software and all the hardware at this workstation. There's a large tower down here at the bottom. That's where the NVIDIA GPU is. We're a NVIDIA GPU house as well as a Basel camera house. You see I've got hand scanners integrated. I've got RFID badging capability. I've even got a torque tool here integrated, all of which I'll be using during this demonstration. All right, so let's get started with showing you how the system works. I'm going to migrate over to the software side of what I'm doing. Ultimately, this is the user side of the software where a user who is authorized to perform certain tasks are able to start a task and start building. I'm going to do this one here at the bottom right-hand corner. Let me start this job. And the first thing you're going to see is our new object segmentation model. And you can see that this is a part identification. And so ultimately, object segmentation is just like how a human sees in 3 dimensions. And as I rotate this part around, you'll see it identifies that part, even if I change the focal plane, get closer to the camera, or I put it any way I want to on this, this exact light table. It's counting the parts as well. You can see that if I move the screw, it actually will track it as it's moving around, just the way a human would. So let me put the last part in place and let's move on. Okay, so now you see the tree structure here on the left-hand side. And these are all the different steps I'm going to perform in this job. Here's the PC, and it wants me to actually scan in the part number for that software. You saw it did an OCR check of the person who inspected that board before. I did it pretty quickly, and we ingest that data as well. Okay, so now you see the video-based work instructions. So ultimately, this video will play over and over again, trying to show the human what to do and how to do it. In this instance, my thermal pad is already placed. So I say, hey, great, this works. It looks good to me. The very next step is going to look at the gap logic between the pins and the pad to make certain that the memory module is placed correctly. So let me go on. You'll see it do that QA check next. Okay, so it liked the placement of that thermal pad. So now it's asking me to install this memory module. So that application is going to play over and over again. Let me install this memory module as best I think, according to the video I see, and move on to the next step. Uh-oh, so I've caused a defect. You can clearly see here that the clip for that memory module has not been fully engaged. And it's actually even telling me that. In fact, if I go and defeat the other one, you'll see that very dissimilar than, let's say, pixel counting vision architecture. Since we're doing neural nets, we can actually classify each defect and it will tell you what's wrong with it. In this instance now, you can see that it knows I need to push the entire module down because it can clearly see itself that it's not even engaged at all. So it's trying to direct the human to get to right the first time. All right, so let me push this down, fix our defect, and move on. Okay, now we're going to scan in the part number for that memory module and retain that documentation. Now it's showing me how to install this daughter board. So let's do that. Let's install it. Move on to the next step. Now it's going to be a torque instruction that's integrated. Uh-oh, I've done something else that's wrong here. Ultimately, I double clutched the torque tool. And what ended up happening is that the rotational angle of what I was expecting to see of 2,208 degrees was not achieved. Now, that could be because of cross-threading, foreign debris, or even the fastener being too short. In this instance, I did it myself just by double clutching, but it captured that as well. I'm actually going to reject this so you can see in the report what this looks like once we finish this complete operation. So let me perform the second one correctly, and then we'll move on to the report at the end of this job. You can see here that we'll have the assembly name at the upper left-hand corner, plus a description. This would be the part number of whatever you're building. I know the operator based off the badging. I know the rev of that assembly, and I also know the time date stamp. I also know that on all the quality steps that I did not engage with, which means I didn't do anything on the user interface, the HMI, we hit 100% quality on everything, except for one that I actually chose to reject. That's why our pass rate's at 90%, because the human intervened, human in the loop. The confidence or the inference is at a 98%. This is actually amazing compared to a human, because obviously all a human has to do is show up a little bit tired. They stayed up and watched a game. They're sick. Their kids are sick. And after lunch, they will get nowhere near that kind of confidence on an inference of what they're doing in their memory. The assembly time, I've got 3 minutes and 50 seconds, which means I'm way over. So I'm obviously talking way too much. So I have a training opportunity. I should have done this job in 1 minute and 23 seconds. So I'm 2 minutes and 20 seconds over. Now, right here in the middle, this is where we would capture the entire genealogy of work orders, part numbers, product keys, and serialization of all the devices that go into this product. This is very important. So if you're getting batches of third-party product into your product, you will capture exactly where that batch is located, all the way to the master serial number and the work order of what was built. Here's the first thing that got rejected, the only thing that got rejected, and it's the first thing on the report. We get full photographic evidence of all work completed, and you can see that it did fail, and that the angle, 1,824, that's the problem, not the torque. The torque was actually perfect. If I move on down, you'll see I also have the kit. So with the object segmentation, I know the exact number of parts, including the part numbers, that all pass with the photographic evidence as well. The other things that are quite interesting is when I get down to this one, the QA dwell. This is where we're leveraging our quality control AI to make certain the gap logic is correct between the pad and the pins. Down here, the clip for the memory module as well, photographic evidence of that one. And then last but not least, we have the correct torque curve and torque angle of the last screw deployed. So ultimately, all of this can be saved as a PDF. And of course, all of it is accessible by our RESTful APIs. All right, so let me move on and show you how that sausage is made. I'm going to click on supervisor, and you're going to see a pop-up come up, and this is for the supervisor to actually use their memory, their badge. So you see I've got my badge right now, and once I engage it, we can move on to the supervisor side. Okay, if I wanted to create a new assembly, I would actually do it right here. What I'll show you really quickly, though, is the library for the object segmentation of all the parts when I identified the kit before I started the build. So you remember I had that daughter board in my hand. And if I move all the way to the end of this, you'll see a much easier viewable size of that daughter board. Basically, you're teaching this to the neural net in 3D. So you see that we actually start spinning around, flip it on its back. You can even show it as on edge to a certain degree so that it can still identify features and edges. Only about 6 to 8 of these pictures are required, front, back, at 45s, all these different types of modes of trying to show it. Once you've shown it, 6 to 8, and not necessarily these ones I've got over here you see in plastic bags, which we're doing that for a med device company, then you will actually teach it and it will know this part in 3D, just like I showed you. All right, so let me show you how the sausage is made. Let me do a quick test build so you can see. I'm gonna call it test. I'm gonna move on. I can choose all the different cameras. In this instance, I'm just gonna move forward and click start. And then we're going to get the no code action builder. This is where we actually can do all these functions, where you actually build up the model. So the first thing I want to do is I actually want to show it a video instruction. Choose the correct camera I want to use for that instruction, zoom in a little bit, click start again, go in here, install that memory module correctly, click finished, and now I've got a video work instruction on how to install the memory module. It's going to transcode this. You can step through really quickly and see if this looks correct to you, and if it does, move on to the next step. At this point, give the on-screen guidance of where it's got to go, and the next step again. Okay, at this point, I want to do a QA dwell. This is when we are actually going to already have the work completed, and if it's not completed correctly, then we have to actually complete it before it moves on. That clip is a great example. Just click start again. Now it's taking the pictures to create the neural net. Perfect. On-screen guidance of what we care about for this QA check. I don't have another correct because there's only 2 options, 1 correct and 2 incorrect. So I'm going to say no. Now, here's where the rubber meets the road. If you showed it what's correct, you also have to show it what's incorrect. You have to treat the AI as if it's a child. So in this instance, I'm going to unclip this, say yes. You can see the differentiation, say yes again. And now we've created a negative reinforcement against the positive reinforcement. Outstanding. Yes. This is also where I recommend definitely putting in notes. I've been skipping through them because this is when the humans will definitely read the screen in order to get to write. And just say, not clipped in, something short and sweet. All right, I do not have another. Let's move on to the next step. Let me do a quick data capture like you saw, specifically for the memory module. Now that I've got it installed, just click start. I know that I believe is the part number on that barcode. And then I also need to show it exactly where to scan. Click on next step. Okay, so let me do a parts verification really quick. Choose cam 5. Let me take out some of these parts. And I'm going to do it with just these and not the daughter board. Just click start. It's going to scan the region. It's going to find the parts and even count them. So it knows it's got a thermal pad, memory module, 2 screws. Perfect. Move on. Let's do an OCR verification just so I can show you how that works. Go to cam 2. Let's zoom into that guy right there. Here's standard tools you can use to your advantage to move around. Zoom in again if it's not tight enough. Perfect. Click start. It's going to try to read everything it can see. You can deselect all or put them all back on. All I care about is that person's number on who did that verification. Okay, now let me go to the all done. So I've got a little 5-stepper here. In this instance, the part verification probably should be first. So basically choose the 4 square, move it to the beginning. Now I've got the video instruction, look at the clip, data capture, and then OCR verification. Great. If I have additional corrects or incorrects, I just choose the pencil, add corrects and incorrects. If I want to delete something, just hit the trash can. If I want to add a step, just add a step. At this point, I like my model. I just click on build. I can build now or later. I'm just going to say start now. And at this point, now we're going to start building our neural net brain for that application. All right, so that is the operation and the supervisor side of how our network works, our infrastructure works. Are there any questions, comments, concerns?
Okay, we got a couple of questions in the Q&A. The first one is, can this technology be integrated into Ignition, or perhaps a more simple platform like Excel VBA?
Could you ask the beginning of the question? You broke up. I couldn't hear the first.
Oh, sorry. Can this technology be integrated into Ignition?
Oh, absolutely, because we use RESTful APIs, and Ignition definitely has that, as well as OPC UA for Ignition. So there would be no less than at least 2 paths for us to get this data up to Ignition. Yes.
All right. And the next question was, does any Gigafactory, are any of them using this technology, for example, Tesla or Amazon?
Ironically, we are talking to Amazon right now, to the robotics team, because of the put and pick robotic systems they have to deploy. So we are actively talking to Amazon Robotics out of Boston right now. We haven't deployed with them, but we're definitely talking to them.
Okay. And then another question was, will the software work with regular photos? For example, at my company, we usually take pictures of our industrial controls when they are finished and ready to ship. If the software can take pictures, it would be nice if we can identify a defect before shipping.
So we don't have that capability right now. However, we are talking with a couple of different customers where we're going to actively deploy that capability. We do have an offline version where we can do that to prove out that type of functional capability without being an on-premise solution. However, again, we are talking to several very large customers, not several, there's 2 specific ones that they want that capability. So probably by second quarter 2026, we'll be able to do that.
Awesome. Are there any other questions? Matthew, do you have anything else?
Yeah, a couple things that I would say that really differentiate us is we are a on-premise solution. That's what this PC is for down here. Nothing has to go back to any kind of cloud infrastructure whatsoever, because we know it's extremely important how your products are put together. And sometimes that's as important as the design side of your product. There may be some idiosyncrasies you don't want people to know about. So we are a complete on-prem solution. Also, too, the way we augment, you saw that journey I went through to start building this model. Ultimately, we are taking those positive and negative pictures that I was creating during the QA checks, the QA dwells, and we augment those. That's part of our secret sauce. And we are hypersensitive to the speed at which we can create those models. So these don't take, days. It's just measured in minutes, depending on what or how big the actual model is. So we take several of those things very seriously. One other thing I would say too is that the video-based work instructions have been unbelievably accepted for many different manufacturers across the country. In fact, to the point to where we have Gen Z new assemblers that once they use it, to them, it almost seems like it's a gamified solution, and they prefer to have our software in front of them, video how to do, they do it, And then if they've got it wrong, our software is telling them that they've got it wrong and how to fix it. And so it's been amazing to hear even management from major manufacturers, multi-billion-dollar companies saying their people only want to work this way, especially the younger generation. So there's a couple little tidbits that we've recognized out in the market that we really are passionate about. On-prem solution architecture, the fact that we build these models very fast, and the video-based work instructions with integrated QA seems to be very useful, especially for the younger generations right now.
Awesome. And then lastly, are you able to provide the cost?
Yeah, so so basically, there's three components to what we do. For the hardware architecture, if somebody was buying all the hardware from us, the PC, the cameras, the touch screen, cables and connectors, all the stuff that's required, other than the fact they've already got torque tools and RFID and probably hand scanners. So we do a hardware component portion of the cell. Then we do a software component part of the cell, and then if we're doing helping do the install for our T&E to actually come on site. So if you look at something like the T&E, let's say that's $7,500 for a week for us to come on site, approximately, rough order of magnitude. The software, you're talking closer to $12,500 a year license, and the hardware closer to $15,000 just for a single architecture 4-camera system like this. So we're trying to price it very reasonably to make certain that you can get a quality control engineer at every single workstation. And the cool thing is these QA AI stations, right? They never show up sick. They work every day and waiting for the person to come and do some work.
Are there any other questions before we wrap up? All right. Thank you, Matthew, and thank you to everyone who attended. If anyone would like to review any portion of this webinar, the recording will be available on YouTube and on our website, enm.com. And once available, you will also be receiving a copy of it via email. Thank you again for attending, and have a great day.